Good morning or good afternoon, depending on where you're located. Today it is Thursday, August 8th, 2019, and I'd like to welcome everybody to the monthly Connexus webinar series. Today we have Dennis Sheridan with Synopsys talking to us about Application Security 101. And I can tell you it's a little bit more than 101, but it is also very great for those of us who are sort of beginning our application security um, trudge through life. Next slide. Our agenda today, I'll go through a couple housekeeping items, talk a little bit more about Dennis and his expertise, a little bit about Conexxus. We'll go through the presentation, and then we'll have questions and answers at the end. Just wanted to remind everyone that the webinar is being recorded, and it will be made available in approximately 15 days. You can find it on YouTube. That is if you subscribe to the Conexus Online section of YouTube, or you can also find it on the Conexxus.org website, and it's under Resources. I'd like to remind everybody that the slide deck will be available after you complete a short survey. So after the webinar is concluded, you will receive an email with a survey link. So please complete the survey, and it's like I said, very, very short. And it also asks for your feedback for future webinars. And then upon completion of the survey, you will receive a copy and a link to the slide deck. Every attendee is on listen-only mode, and their microphone is muted. So we do ask that the questions be typed into the GoToWebinar panel or the interface under the Questions tab. And please know specific vendor questions. And if you would like to submit a request for PCI continuing education credits, please contact Allie Russell or arussell@conexxus.org. And if you do have any other information, you can also email Conexxus at info@conexxus.org. Our host today is Miss Allie Russell, so thank you, Allie, for your help today. I'm Cara Gunderson. I'm your moderator. I am the chairman of the Conexxus Data Security Committee. By day, I'm the point of sale manager at Sitka Petroleum. And so today we're very happy and honored to have Dennis Sheridan, who's a managing principal from Synopsys with us. And he runs the consulting services for Synopsys for their software integrity group, specifically in Texas, Oklahoma, Louisiana, and Arkansas. And Dennis has been working in the application security and software development industries for over 15 years. And he's been involved in Conexxus since 2017, and Dennis has been a huge contributor. So, so Dennis, thank you for joining us today. A little bit about Conexxus. Conexxus is an independent, nonprofit, member-driven organization. And really what they do is there's a very few staff members, and then there's many of us, like Dennis and myself, who volunteer and really are the large contributors to Conexxus in setting those standards, because they set technology standards for the U.S. petroleum industry regarding data exchange, security, mobile commerce. They provide vision and really are an advocate for our industry. You can see Conexxus attending many, many different groups and representing the overall U.S. petroleum industry, so we appreciate them. We have a very great webinar schedule here. I just wanted to let you know that, again, all of these are recorded and available to you either under YouTube, under Conexxus Online, or on the Conexxus website. So we've had some really great webinars, as I mentioned, really focusing a lot on data security. We've seen so many data breaches in the news, and unfortunately it's becoming more and more common. So we're very happy today to have Dennis doing one of our August webinars. Also coming up, we have Don't Get Phished, Train Your Employees to Avoid Ransomware. At the end of August, we have updated science presentation in September, and that's focusing a lot on the managed detection and response, the MDR. October, we have Easy PCI and how to make PCI and attestation easier. And of course, in November, we're going to be talking about EMV implementation. And then in December, it's going to be the applicability of PSS requirements for merchants and the managed network service provider space. So, and like I said, we are looking for webinar ideas. So if you complete the survey, we would love to hear your thoughts. Just wanted to remind everybody that if you have some availability in your October schedule, please join us at the next show. It's always a great, huge show, as pretty much everybody knows. And Conexxus leads the Tech Edge series. So you're going to see several of us speaking at NACS as well. And with that, I'm going to turn this over to Dennis. So Dennis, thanks again for sharing your knowledge and your time today.
Okay, thank you very much, Kara. We're here today to talk about Application Security 101. I have previously given a webinar on application security topic. Seen the great presentations that happen at the Connexus conference in the data security track, and just thought that there's a lot of focus on penetration testing and scanning. So just want to talk today about all the other type of activities that fall under application security. And what I really want to spread today is sort of a message that security is not something that we want to try to test into our software, something we want to have at the forefront of our mind as we're building it, so that we're making it secure from the ground up, and we're not relying on bolting something on at the end to fix any holes that may or have occurred. And I think that this is good today to talk about this because as teams are becoming more agile, as they are adopting continuous integration and continuous deployment practices, they're really looking for ways to bake security into their software development lifecycle. And so that's, I just want to focus on what are different activities that can occur, and just educate today's audience on that. So specifically, the goal is to raise awareness among both builders and buyers of software. Conexxus is a very interesting group because there are a lot of merchants in there that may not be writing software themselves, but they definitely are purchasing a lot of it and integrating things in their environment. Hopefully today's talk is also relevant to those Conexxus members that are the vendors and are building their own software. Point of sale vendors, back office, accounting software, and just so that they can see, oh, okay, we're familiar with scanning and pen testing because of how large PCI compliance looms in this space. And this is to give some more information just on other application security practices that firms are adopting both in this industry and outside of this industry. After getting some good feedback from my last webinar, I'm going to focus more on breadth instead of depth this time. But if there are additional questions or you would like me to go deeper on a particular topic or activity, please don't hesitate to put a question via the little chat interface, and we can pause and I'll do my best to answer those. It'd be interesting to have this be a little bit back and forth if possible. So, if folks want to contribute some of their experiences, or sort of have questions about how to adapt this, please go ahead and put those forward. Okay, so just a few quick slides on what a secure software development lifecycle can look like. So to start with, let's just cover what a generic software development lifecycle likely looks like, right? So your company has an idea for an app or some sort of service that they want to provide to the customers or another business, right? So you go from the ideation of this solution to designing it, Once the design is settled, you gather requirements, sort of put together a high-level architecture, go about implementing this. It's going to go through various phases of testing, user acceptance testing, functionality testing, unit testing, and then ultimately, once everyone's happy with the results, going to ship it. It's going to be out there in production. People are using it, and now it is in kind of a maintenance and operational mode. So usually in that model, what we find is that once the product is about to go live, that's when it would usually occur to someone to say, hey, is this thing secure, right? So I've definitely had lots of experiences during my time in the security industry where we sort of get called in and say by a customer that says, hey, we just built this thing and can you do a quick pen test and let us know that it's secure? So, it is good to do that, right? Do something before letting it go out. But we've seen a trend for people trying to bake this into a secure development lifecycle. And these are processes that complement those traditional development tasks. So what you'll see is sort of at each of those steps that we went over on the last slide, there is a complementary security task that can be performed. And each of these have a unique focus, and they are better at identifying some types of issues or concerns than maybe other tasks are as you get closer and closer to deploying that software. So this is just a list of some of the activities. What I am going to do in the next set of slides is to dive into these in general and give some more information on it. But before doing that, just wanted to go over sort of in the security methodology at a high level, right? So for these tasks, what we are trying to focus on is, how can things go wrong, right? What would someone try to maliciously get out of our system, right? We have important data, customer information, maybe proprietary information, maybe there's some sort of monetary rewards. I'm sure like somehow enabling something to give you free gas would be something that you don't want to happen. And those folks either in your company or in a variety of other security consulting services, that's the mindset that they're bringing. And so when everyone's thinking about, okay, well, what's this app supposed to do? They're really thinking about how can we make it do the things that do the exact opposite of that, right? How can we exploit the system to do the things that we're not supposed to be allowed to do? This is done via like two ways that I usually think about this. So number one is identifying vulnerabilities, and these are known issues, right? Tools are the best way usually to go about detecting them because they can scan much quicker an application, some type of system looking for known problems and report back than a person clicking around on an application can. But on the flip side of that, the other thing that security folks are looking for are to break assumptions. And this is something that would be more well suited towards manual testing because it takes an understanding of the business logic. What is this application supposed to be doing? And what assumptions might the developer make while they're coding an app, right? Because they're thinking about, okay, I need to make this thing work on the happy path. Thinking about how things can go wrong might not be at the forefront of their mind. And that is where I would say, the security folks find a lot of the highest severity type of issues. I will do my best as we go through the description of each of these different types of SDLC activities to to, at a high level, just sort of say, okay, here's an automated approach. If there's an automated approach to that type of activity, or if it's mostly manual, and sort of debate share the pros and cons of those. So, like I said, we'll just go through at a high level the activities, and if there are any questions, just please share them in the chat, and I can pause and elaborate more. So to start off with, wanted to talk about abuse cases. This is just the better sounding name for security requirements, and much shorter and easier to fit on the slide title. But this is the complement to use cases, right? We're going to list out what our application should do. And I know that it might seem maybe like redundant to say list out those things that it should not do, but the real benefit there is bringing security into the mind of those software stakeholders, right? What we want to ensure by doing this is that, we're not giving ourselves a chance to make false assumptions, right? So when we say that, only this person should be able to edit their cart, I mean, obviously we would assume that, yeah, not letting someone else edit your cart just goes without saying. But if we don't state, there's a benefit to stating it, because it makes people think, oh, okay, when I'm validating whose cart we're looking at or whose cart we're editing, I want to make sure that we're not letting people edit the contents of another person's cart, right? A lot of security, and especially software security, is about a culture change, a mindset change. And we find that security requirements and abuse cases are a good way of doing that. This picture, just some sort of stock image that I found on the internet. I'm not advocating for folks to document lots of these things, especially as teams are becoming more agile. The real point to take away here is, bringing up and sort of identifying, making sure that what the app should not do is part of the conversation, right? And again, while we're in that requirements phase, we are making sure that we're bringing this up before we've written any code, before we've designed anything, because the faster we identify and stop things from being introduced, security vulnerability-wise, the cheaper and faster it is to address them.
Hey, Dennis, we had a question come in. It asked, can you talk about some of the side channel vulnerabilities, specifically like around Spectra and Meltdown, and how the secure SDLC process can mitigate the sophisticated attack vector?
Sure. In fact, I will try to do that via this next activity, which is threat modeling. Okay.
Perfect.
So, so let me talk about this activity first, and then I'll do my best to address the question. So the next type of activity is threat modeling. This is going to happen as a complement to the design and architecture phase. And this consists of figuring out, hey, how are we going to build? What are the pieces that we need to build our application, right? Once we identify what those pieces are, we might be choosing specific technology stacks. And as I'm sure a lot of the merchants are aware of in Conexxus, there's a lot of integration that happens, right? You need to work with one vendor for one particular service and another, like you probably have a whole lot of vendors that you're integrating with, and your data flow is going to show, oh, okay, we're getting the data from the consumer, but then we send it over here, and then those guys send it to someone on their back end. And the goal of threat modeling is to identify all these components, show where data is getting sent, and then we will overlay what security controls exist. So the picture that I have on this slide is just showing a whiteboard of a sort of generic application, okay? in threat modeling, what would happen here is they would talk about the protections that would exist for any of these data flows, which are represented by the arrows here. You also outline what security controls are used for that communication, what data, and in particular, what sort of sensitive data. That could be PII data, that could be payment data, anything proprietary to your company that you feel that you recognize as being sensitive, to help identify where that information is flowing. So what we try to do here from the security perspective is to see, once we finish our threat modeling exercise, are there any arrows that don't have a particular security control there, so that we can identify, oh, okay, are we sending sensitive data off to a third party, and maybe we haven't done a review of them, or we're not sure what they're doing with it, right? So that we know that we need to follow up with them. Maybe even inside of the components that you control, there might be a missing control. So we're trying to just identify assumptions here at the design level, and so that we know, okay, as we go next into the implementation round, what do we need to plan for in terms of building security controls, testing security controls to make sure that they are sufficiently protecting the assets that we need protected, right? Okay, so back to the question. How could something like this help a sophisticated problem? Well, sort of if we go to abuse cases and threat modeling and looked at them together, meltdown is about allowing a rogue process to read memory, right? And exists because because we're doing something, like the implementers are doing something to improve performance so they're doing something to improve performance that is opening themselves up to an attack, right? So I'm not sure what the conversations were like when this vulnerability was or problem sort of manifested, or if they had considered this, but it's really there was a trade-off made between performance and potentially security. So perhaps having someone in there that would think maliciously about, hey, if we read, doing a whole bunch of look forwards and we're reading a whole bunch of extra stuff into memory, yes, that's going to be more efficient, but are we opening ourselves up to an attack? And when they're diagramming out how this process works, I mean, a threat model doesn't necessarily have to only be for an application and its components, but it could be something around how a particular process works or a workflow. Maybe it could have been identified there. But the whole point is that at each step of the way, we want to diagram how, let's diagram our system, our protocol, our workflow. Let's take a look at the security controls that are there, and let's just take a second to think, hey, how could things go wrong, right? So that, without sort of diving way into the weeds on details, I think that just in general, that approach could help to mitigate or hopefully catch something like that in the future. Last thing I wanted to say about threat modeling, this is not only an activity that is specific to when you are building a new application. Lots of times you have an existing thing or application, and the environment that it's in is changing, right? You might have something that used to be on a closed network and now you're opening it up to the internet, right? You might have something that only communicated with one outside vendor and now it's communicating with multiple outside vendors. That sort of changes the landscape of threats that you would want to consider. And threat modeling is a good exercise just to diagram things out and make sure, hey, given our previous state of the world when we deployed this application, did we make any of those trade-offs did we say, oh, okay, we don't need to worry about this security issue because we're on our own internal network, right? Well, now when you take that thing and you hook it up to the internet, now you have to worry about those things because the environment that it's been placed in has changed. And this is a good way to try to identify in which ways that it's changed and what that security impact would be. Okay, next up, secure code review. This is something that is most often done, I would say, by an automated tool, particularly static application security testing tools. However, it can be done manually as well. What this involves is taking a look at the code, and we're trying to identify sort of two things. Number one, are they using any known bad functions, let's say? So finding vulnerabilities that way. And for more sophisticated SAST tools, they can be part of the code as it's getting built, and they are able to trace the input from one area of the code through the different classes and files that data will traverse until it ultimately gets stored in a data source somewhere, or displayed to the user on their phone or their computer screen, and see, okay, did the appropriate security input sanitization or cleansing routines run so that we know that we are not going to be introducing something like a cross-site scripting vulnerability. These tools can run in a variety of ways and in a variety of places, right? So they can run in an IDE, which just stands for Integrated Development Environment. And you can just think of that as the Microsoft Word for writing code, right? It's like the application that the developer is going to open up when they're writing their code. And so there are SaaS tools that can live in there. And as they're writing their code, they can scan them almost like spell check does in Microsoft Word. There are more robust versions that might run when developers check in their code. It might run whenever they go to build their code, or might just be set up for a nightly scan or on some sort of frequency. And these can do that more complicated data flow analysis. Typically with the IDE ones, it's doing more of just the, hey, are you using any bad routines? It's kind of looking at that file. One thing I wanted to mention here also that I felt like falls under secure code review is reverse engineering. Reverse engineering is where you've written code and it's on something that is, let's say, out in the world, right? So I guess the best example of this might be you wrote a mobile application, and once you go and distribute it through the app stores, folks download it on their phone, and they have that code that your guys wrote on their phone. So, if they're savvy enough, they can take that application off of the phone and run through some tools, and it will give a very good approximation of the code that those developers wrote, right? And so they don't need internal access to your source code repository to see what things look like under the hood. They might be able to do it that way. And I use the mobile phone example, also true for like anything IoT device related, or anything where they write software and then it goes and gets deployed in either your environment or some other customer's environment, right? So I put a little star here because as an acknowledgement for the sort of the merchant vendor relationship, you may not be able to do this if you were interested in, right? Because of EULA agreements, or they might say, hey, by purchasing the software, you agree that you are not going to do this. So I'm not advocating for anyone to break those, but just wanted to put forth this, that just because there's a piece of paper that's stopping you from doing it, it doesn't mean that people out in the wild are not doing it, right? So if reverse engineering is a concern, maybe as a software provider, looking at security solutions that can help protect your proprietary code or make it more difficult for an attacker to try to reverse engineer what you've written, that's a good way to bolster that as well. Okay. Next slide is on open source software. I wanted to include this as we were talking about secure code review. This iceberg picture here really sort of represent the code that is inside the applications that either you're writing or you are buying. So the tip of the iceberg is the code that the software provider is probably have written, right? Once that code is out and deployed, it's running on a lot of open source code. I mean, it can probably include a lot of open source code in their application as well, but things that you don't control. But the problem is when you pull in these open source libraries, the vulnerabilities that are in there, they become your vulnerabilities, right? Those are security issues that are existing and now running in your environment. So open source software has been a pretty hot topic for the past few years because it touches on two things, really, like both legal concerns and security concerns. So for open source, each little bit of open source that's out there, these projects, they have a particular license that's associated with them. And your legal team, even as a, if you're an acquirer of software, so you've hired someone to write a bunch of software for you, or you're a software provider, right? You're the one that is writing it. Your legal team might be concerned too that including particular open source would say, by including this package in your code base, this entire application has to be open source, right? So you'd have to put all of that code that you paid your development teams and your architects and you spent a lot of money developing out there if you wanted to go forward and continue using that open source package. So it's to try to save from any legal headaches. And then I talked about the security concerns. The open source projects that are out there, there's a great community. They're putting new versions out there all the time. But so you want to keep an eye on it to make sure, hey, are we at that latest version? Because as vulnerabilities, also known as CVEs, are found, these subsequent versions might be addressing them. And so this is a good way to check to make sure that you are aware of risk that might be in there. And in particular, I've seen a lot of interest in this around mergers and acquisitions, right? We're about to spend a lot of money acquiring another company, and we want to make sure that we know what is inside this code that we wrote that might have landmines with regards to legal or security issues. Okay, next up, security testing. There's a lot of different things to talk about here, so I'll try to be brief. Security testing has automated and manual approaches to it. So I'll start with some automated approaches via talking about dynamic application security testing, or DAST. This is where there is a scanning tool. They're mostly, I guess, most experience with these is focused on web application testing, web application or web services testing. And this is a tool that needs to be set up and run by a person, so kicked off by a person. It's going to crawl an application. It's going to identify a bunch of inputs, and it's going to try to jam a lot of bad security payloads in them to see if it yields any unwanted results, right? These things can be tuned and made better by having a person click through and train that tool so that it has a better understanding of what the application does in terms of what types of inputs the app is expecting in order to progress through certain workflows. So, this tool might not know that, hey, you can't progress to this next page of an application unless you put in a particular zip code that's in this state, or unless your birth date is after such and such date, right? So that those are useful things that that person that's running the tool can do to improve your, let's say, improve the results that you would get out of this tool. There is a new type of security testing tool out there, and it's called Interactive Application Security Testing, or IAST. This focus is more on saying, hey, we know that there's a big focus in the development community nowadays on testing, and specifically automated testing, right? So folks want to deliver code faster. That means that they got to automate more of those manual steps. So we're doing our best to automate functional testing that might happen after we make a change, right? So we're going to regression test the old functionality. We're going to add new test cases in to test the new functionality. And the idea behind IAST is, let's just put a little agent on the application server, and as those tests are run, this agent's going to see those requests that come through and inject security type of tests into them, right? So the idea is, let's leverage someone else exercising the app. So either your automated tests or your manual testers, doesn't matter. It doesn't matter what's driving the application, but as it's going through its different workflows, its different routines, you're going to be getting these security tests that you would expect to find in DAST without having someone to drive that or configure this tool, right? So the things that get tested, the areas of the app that get tested functionally, now they're also getting tested for like with security test cases. Next one is Fuzz Testing. This is more geared towards protocols. So if there is a special way that some particular application is communicating to a server or another application, Fuzz Testing its objective is to send lots of bad malformed requests, malformed packages, like huge data sets to whoever's listening on the other end in order to try to cause a failure condition with the hopes of identifying a failure condition in which the system would fail open, okay? So you're really testing, the focus here is on those messages that are going back and forth and making sure that whoever's receiving them or listening for them is robustly handling weird error conditions. This is most successfully done in an automated fashion, just because this tool a tool is much better at spamming a particular endpoint than a person would be. Although coming up with different types of tests and designing what types of malicious data should be sent, that is a feature of a lot of these tools. So you get out of the box functionality in them, but you can also customize it to make sure that you're addressing either unique characteristics of your protocol or unique conditions to your environment. Post-deployment testing, I actually skipped one. Penetration testing, although I think that this is the one that folks on the line are probably the most familiar with. This can be done, I'm sure a lot of you are familiar with network pen testing and application pen testing, thanks to PCI's requirements. When I was talking about security methodology earlier, the real goal for pen testing is to try to identify any assumptions that a developer made, right? And you can always tell when you uncover an assumption, because when the pen test is done, the results are found, and then there's a list in there that says, hey, here's how we found this SQL injection attack, and here are the steps to reproduce it. And as you're going through the steps to reproduce with the developer, they hear them say, well, why would anyone ever do that, right? Like, why would someone proxy my traffic and send something that wasn't allowed to be sent? And that's where you can always identify, oh, okay, this is something where, they made an assumption because maybe they just didn't know better. They didn't realize that that was something that they need to be cognizant of to protect against. Like I said, that's where we find the most high severity type of issues are when we uncover things like that. Pen testing usually will contain DAST testing as a subset of it. So, the pen testers usually will be running automated tools first or in parallel with what they're doing, just to have a tool go out there, spider things, try to find, hey, are there particular areas of the application that have some vulnerabilities that I, as a person, can think of, oh, okay, well, if that vulnerability exists there, then maybe I can chain that with some other type of attack and take one security issue and try to chain it to others to pivot and find some sort of exploit that where the sum is greater than like the individual parts, right, in terms of impact. Post-deployment testing, these previous activities I talked about, these typically happen in a pre-production environment, so your staging environment, QA, UAT, whatever you might call it. Post-deployment testing is just making sure that, okay, once we take that code, we deploy it to production, did we do that correctly? Because sometimes there's parts of your application that are unique to the environment that it's in. So your certificates, you probably have different unique certificates for your pre-prod environments than you do for your production, right? The instances that you might be of third-party vendors that you're talking to, probably different once you move from pre-prod to prod. So this is sort of identifying, hey, what aspects of the application might be impacted, and that might be different, I guess I should really say, when you move from a pre-prod to prod environment, okay? And just making sure that, okay, did we get those parts right? Finally, red teaming. This is a type of testing where the security folks will just emulate real attackers. So it can really encompass a whole variety of, let's say, testing techniques, including more of social engineering and phishing and even physical things like trying to pick locks or do USB drops at your location to see, oh, okay, did we train our people enough to know if they find a USB lying around that has somebody's name on it, right? They're not going to try to just go plug it into a computer somewhere. So there's a lot of different areas on that, but at a high level, these are goal-based tests where you really say, hey, we're in production. We have this type of sensitive information. We're going to hire someone to go out there, attack us like an attacker would within whatever rules of engagement that you specify, to see if they can find a way by any means necessary, if possible, to get that information, right? So it's sort of validating the efficacy of your controls, in the real world. Okay, last type of activity I wanted to talk about was sort of operational security. So this is, once everything's in production, what are some application security things that can be done? Well, there are web application firewalls that exist. Just like you have a firewall on your network, there's a similar thing for web applications. It's trying to stop malicious payload. So if it thinks that someone's trying to send a SQL injection payload or a cross-site scripting payload, right? It will hopefully try its best to identify that. And then it can do two things, right? It can either just alert and let someone know, hey, somebody's trying to send what we think is a security payload into our app, or it can try to block it, right? These things also have to go through a little bit of training so that it can try to figure out, oh, okay, based on what this application is doing, we find a lot of false positives when we try to block using this rule. So there is a significant training period that needs to be done for some of these. And, you do run the risk of interrupting, let's say, normal or allowable interaction. So you could err on the side of caution, but really with a false negative, right? So that might not be the best user experience. Someone's trying to submit something to your app and all of a sudden it's failing. So that's why it's, takes a bit of training. Make sure that you're really checking to see that you're still passing all these user acceptance tests with a WAF in place. There is also runtime application self-protection, or RASP. This is sort of a new area. The focus here is on, it's almost like a WAF, but sort of built into the application. So the application is going to take a look at incoming requests, and it can do the same things. It can alert, it can block, it can do, but it can also take other actions, right? So you're sort of coding these protections into the app to try to like have the app be able to do this as it's running, okay? And again, this is, I like, this can be implemented as like a tool. I know OWASP has like a framework out there that you can include to try to do RASP functionality. I think the thing that I like about RASP are the ones where that you have to, like, even though you have to implement these, okay, well, we detected something bad, what are we going to do? Like, you have fine-grained detail of, well, we still want them to be able to peruse a site, but maybe we won't let them, do any purchases or something like that until they authenticate again. So it gives you fine-grained control, but it goes back to that sort of abuse cases task from earlier. It's making you think of, well, what are the bad things that we should be looking for and therefore preventing, right? It really hammers home that that idea in the development teams. For both of these two tasks, I think obviously everyone's preference would be, well, let's just build the thing securely from the start so that we don't need to have these things running in there, right? So these are, I think, sort of best viewed as, something that complements. It's not a full replacement for those security activities that should be happening during development. Next one up is code protections. What I'm talking about here are just those things that you can do to your code so that once it's out there in the wild, it makes it a little bit harder for those attackers to try to either figure out what your code's doing or get to proprietary information. So this can cover things like code obfuscation, which it basically gives all the variables and stuff in your code just very weird names to make it harder to understand what type of data is traversing through the application. There are lots of vendors out there that do mobile app protections, right? So if you have a mobile app and it's got proprietary info on there, they've got ones that can help to do DRM, try to make it harder to reverse an application or manipulate what your application is doing at runtime. These are all, the aim here is really at increasing the barrier to successfully be able to take a look at what's running under the hood effectively. But I won't say that this would prevent someone from reverse engineering an application 100%, right? It's really raising the bar and making it much more difficult. So final thing I wanted to talk about here are bug bounty programs and then also responsible disclosure. I'll just start with responsible disclosure first. This is where your company is just sort of putting yourselves out there to say, hey, if you found a problem, a security issue in something in our environment, right, in a particular application, or just in general, here is a means to communicate that to us. And so it could just be an email address, phone number, something that's published on your website, so that your company can work with that person that identified it to learn about what this issue is and ultimately, fix it, right? Bug bounty programs exist in this area. So they're very popular ones, really big company names that are involved with these and paying bounties for things that people disclose to them, right? So if you don't feel like your company can, has the ability to run this type of program yourself, these other companies can provide that service for you. And so what they'll say is, you would go and define the scope and say, hey, we want these applications to be in scope for, the bug bounty program. These are the rules of engagement, right? Here are the types of bugs that we're most interested in. Here's the types of bugs that we won't pay bounty for. Real low-hanging fruit. You cannot try to DDoS us. That, don't try to do that. You're violating the terms if you try to do that. You won't get a bounty. You can specify the minimum and maximum bounties. I know Apple has a maximum bounty of $200,000 through one program. There's a lot of people. So there are other ways to get security information out there, or get security vulnerability information even after the fact, right? After your software is running. Okay, so bringing this all together, at the end of the day, we're making risk decisions, okay? And we're not always going to get a perfect report card where we even have grades for all of these activities, right? Depending on where you are in the producer-consumer relationship of the software that you're using, if you're the one writing it or you're the one buying it, right? You may not have the access to go scan the source code because it's not your source code. It's the source code of the person that you bought it from, right? So you may not have that information, and you can certainly always ask for what security things are being done and what the results of those were, but can't guarantee that you're always going to get it, right? So we're making these decisions off of the information that we have, and what we just want to do is, we want to identify, what are our biggest concerns about this application? When we think that it might introduce risk to us through these various ways, and all we want to say is that you want to make sure that those software or application security activities are being performed that best answer that question, right? So if you are really concerned about encryption of data that's getting stored on an app, pen testing is not the best way to identify if that's being done correctly, because a pen tester is not going to have access to see where that encrypted data is. It's not going to know unless something is horribly broken in the application, right? But if a secure code review was done, then yeah, you'll see the exact library that was used for encryption. You're going to make sure that it was properly configured and set up, and so that's going to be the best thing, the best way, the best activity to alleviate that concern, right, or to address that risk. And then, I'm sure, as many of you know, you've gone out there, you've done pen tests, and you get reports back, and they've got their different severities, but the thing that I find is it's really make sure that those results are getting tied back ultimately to the business impact, right? So you have a high security finding. Make sure you're talking with the developers, with the business team, to really say, okay, yes, this vulnerability does exist. It was identified in the environment that it's going to be running in. What risk do we really feel like it poses to us, and where does that fall on our company's risk appetite, right? Because yes, there can be certain things that are identified, and it's not a false positive. It's really there, but the company's got to release that to go to market, and it's a conversation, and maybe addressed through saying, okay, we will go, but we have to fix it within a week. So we are comfortable having a window of exposure there so that we can get our product out there, but we're committed to making sure that it's secure. We're going to address it right away. I mean, these are the kinds of conversations that happen all the time. And even if you are a producer of software, it's a journey through trying to do all of these different activities. So I don't expect everyone to be doing every single one of these activities every time that they release code. But as we see a convergence between normal SDLCs, secure SDLCs, and everything being automated in a pipeline, I think that we're definitely going to see some improvement there. So last thing I just wanted to say was, again, you're the merchants, you may not have access to all these things. You may not be the ones that are performing these activities. So maybe a good proxy to address security risk is to take a look at folks' application security programs, right? So what we're just saying is, what is the company defined approach to application security? What are the steps that they themselves say they're going to follow each time that they write something and test something? This might be a good way to balance even internally or balance your concerns to say, yes, we're comfortable. We didn't get the exact pen test results or secure code results for this product, but we did thoroughly go over what their program is, and we believe that it's a robust security program. So we feel comfortable like not having that particular like low level of detail. And then also, just when you are talking with your vendors about it, just trying to identify, hey, how are you adapting to changes in development landscape? So sure, everyone's aware, big push to the cloud right now, sort of introducing a lot of things that were infrastructure that you controlled are now in the cloud, are now being defined by software you write, or excuse me, code that you write. So making sure that you're getting those things taken care of. So are they applying those software security steps to and post-deployment checks to those unique features of operating in the cloud? So that wraps it up for me. I can take questions now.
Sure. Dennis, thank you very much. That was very comprehensive and very thorough, so we sure appreciate it. I know we're getting close to the top of the hour. Had another question come in, and then I have a couple of my own, but what are your top 3 cybersecurity protective measures to apply when you're purchasing a third-party developed software app? Like especially when you're talking about electronic payment processing, maybe a point of sale. So what would be your top 3 cybersecurity protective measures to apply when you're purchasing that?
Sure. So I would say for these, if we just wanted to tie them back to these activities, I would say secure code review, important, right? This is an example of a thing that's running out in the wild, right? It's out there in the real world. So making sure, and it's handling sensitive, we know it's handling sensitive information, and we know that encryption is important when dealing with payment information, since we're talking about a point of sale here in this example. So I think secure code reviews are important. The threat modeling is important, understanding how that point of sale is going to operate in the wild, what other things it's going to be communicating with, right? And who controls those things, what are the communication channels that are used, what the network is, and what are the controls around the network that this thing might be living in. And then finally, penetration testing. Like let's test where the rubber hits the road and find out, okay, now that we actually have it, what bad stuff can a person do once they get their hands on it?
So getting to the source code, for source code review on that is kind of difficult because you've got, especially in a point of sale vendor situation, you've got it out there in the wild in many, many cases. And so they may be very reluctant to giving you that information because it's a whole lot of secret sauce, so on and so forth. So is there a compensating control for that, or what would your suggestion be if merchants couldn't get that review?
Sure, that's a great question. That's definitely one of those examples where it's an activity that as a merchant you would not be able to conduct yourselves, but it's one that you can either ask about directly to the vendor, or as that last slide sort of mentioned, just about their program in general, right? Does your vendor that's providing that to you do static analysis, right? What kind are they using? There's I was trying to be very brief, then I definitely probably went a little longer than even my brief version was supposed to be. But there's different tools out there. They find quality issues, they find best practice issues, they find security issues. So finding out what tool they have, how often it's run, what kind of rules are in there. So, is it looking for, are they scanning code? Yes, we are scanning code. Okay, does that scanner that you're using have security checkers in it? No, it doesn't. Just make sure that we're not violating any of our best practices around how we write code, right? So I know that I had to be brief on this one, but hopefully the idea of this talk was just to be able to enable merchants to start the conversation, right, around, hey, do you do this? Do you do that in the software that you're going to be running in your environment?
Yeah, because I mean, as a merchant, that especially in the payment space, you have to adhere to PCI or payment card industry compliance, right? And so as a merchant, it is your responsibility to do your due diligence. And it actually, states in the PCI regs that you have to do your own testing. Because ultimately, at the end of the day, the merchant is 100% responsible for the data, regardless of where it comes from, how you use it, who uses it, what devices you're using. It's still your responsibility at the end of the day. So that is a challenge that that we as merchants do run up against every day. Because especially in the U.S. petro space, we have to rely on third parties because very few of us write our own software.
Oh, right. Yeah, I mean that is definitely the normal, let's say, like use case for members in this space, and again, that's why I think sometimes maybe it was my last slide today, but that might be the starting point for future conversations, right, with vendors or new vendors that you might be bringing on. Is, hey, you tell me about what your application security program is, and then I can now ask you some questions in more detail about those specific things that might comprise it, right? And ask questions like,
right.
oh, okay, I noticed you do a lot of testing, but not a lot of, you do a lot of pen testing in your app, but I didn't hear anything about source code review. Do you guys do SAST? Or, just give you guys enough information to be dangerous.
Exactly. And then don't forget to write those testing stipulations into your agreements so that you have the right. That is a big part, because so many people just don't want to give that up, and then they fall back to saying, well, that's not part of our agreement.
That is an excellent point. Today's talk was definitely about more focused towards software development lifecycle security activities. There are a range of things outside of just people typing things on a keyboard, right? That go into making or that go into the overall security of an application or a system, and contracts are one of those things, right? Making sure that your company is protected and also has the right to get information or conduct activities to make sure that you're satisfied with that, that what you're buying falls within your risk appetite. Yeah.
Right. Yeah, I know the PCI Security Standards Council released a great document called Third Party Security Assurance Guidance, and it basically helps a merchant kind of wade through the decision-making process on who to use. So that's a great reference document, amongst many others. So I know we've gone way over. Dennis, any final thoughts, or are we ready to wrap it up?
I think ready to wrap it up.
Okay. Well, thank you again for your time today. Thanks for everybody attending today. And you can find Conexxus at Conexxus.org. Again, email Conexxus at info@conexxus.org, and or follow us on LinkedIn and Twitter. So thanks for your time today, everybody, and have a wonderful day.
Okay. Bye.